All right, welcome to the final video in this series. I'm submitting a job application to be a AGI engineer at aigo.ai. So let's take a look at the job post. If we go down here to careers, we can see the job post looks pretty much like it's calling out perfectly to me. I have met Peter Voss multiple times, and yeah, it's exactly what I'm looking for. It says it's not a typical 9 to 5, and they're really driven by their passions. So I did a kind of self-discovery thing where I had to figure out 3 words to describe myself, and the words was healthy, skilled, and passionate. And yeah, I want a job where this is what they're doing. They're on a mission to change the world, and they really believe a lot of almost like kind of things that would seem a little bit crazy to the average person. Like I'm looking for that. This is right up my alley, and even better. For this particular AI job, prior AI experience not only is not required, it could fundamentally be harmful because they're taking a approach known as cognitive AI. And all of the current approaches out there are statistical AI. So your prior experience not only isn't relevant, it could make it so that you kind of have to unlearn or unthink the approach that you've been doing before. So you do need work experience. They want you to be reliable and to be able to work on stuff, but you don't need experience in AI, full stack, communications, cloud, or security either. The focus is different than that. It's a cognitive AI focus. They want strong analytical thinking and problem solving skills, and I feel like I really have that because, especially with my network engineering background, problem solving skills are essential there. So they are using .NET Core and C Sharp, which I don't have experience with. I'm a Python guy, but hopefully this video series will demonstrate my analytical thinking. So I feel like I'm a good candidate, honestly. Like, they're looking, they're not your typical 9 to 5. They're kind of, they're not looking for just the average regular, or they're not looking for, just anyone with AI experience. So I feel like if they're looking for someone a bit unique who's really excited about the idea of being part of something that's not typical, then I'm a really good candidate. All right, so and let me read a little bit about analytic. Okay. Especially, okay. All right, so they're looking for analytic reasoning. Let me type in degree. Okay, yeah, so they might be looking for data scientists. But anyway, I think it's at the very least worth applying. It's interesting too. It's just this. As part of this channel, I read Situational Awareness by Leopold Aschenbrenner, and this is kind of a logical next step beyond that. So it's relevant to this channel, and it's something I'm interested in. It just makes all kinds of sense. So let's focus on this one next. Let's try to get through all the articles and maybe even the white papers and get this application submitted today. So this is the 7 deadly sins. Okay, so I'm going to read this and then mark off that it's been read. The seven deadly sins of AGI design. The term AGI has been badly distorted and abused, be it out of ignorance or for fundraising purposes. It properly refers to systems that can autonomously learn to perform novel human-level cognitive tasks given limited resources of time and compute. Essentially, what a smart college student could learn by hitting the books. They could learn to become a skilled programmer, accountant, or a research scientist. From this, it would follow that A, AGI would be even more valuable than electricity, and B, deep learning and large language models, LLMs, won't get us there. And I'll do a sound check here. It looks good. So why, in spite of tens of billions of dollars and thousands of PhD level AI researchers working on this for 10 years or more, don't we have a clear, obvious, and generally acceptable path to AGI yet? A one-sentence summary is that the tremendous success of big data approaches over the past 10 years has sucked all of the oxygen out of the air, and viable alternatives have not been pursued by enough people with meaningful resources. A more detailed analysis exposes several common key mistakes that have prevented meaningful progress towards real AGI. I call them the seven deadly sins of AGI design. And here they are. Number one is, a focus on knowledge, not learning. Number two is narrow instead of general. Number three, external control instead of self-adaptive. 4, pre-trained instead of incremental real-time. 5, quantity of data instead of quality. 6, statistical and not ontological. 7, more generally, lacking a robust theory of intelligence. So intelligence is a force that maximizes future freedom of action. Okay, well, moving on. Focus on knowledge. There's a common misconception that knowledge is a good measure of intelligence. This is not so. An encyclopedia has a lot of knowledge, but no intelligence. We also all know people who are quite knowledgeable, but seem to lack in intelligence. In other words, on the other hand, we know the Bushmen of Africa who grew up not knowing books, electricity, or cars, and yet able to learn to succeed in a large modern city within a short period of time. AI development over the past several decades has focused far too much on having knowledge and skills rather than the ability to dynamically acquire, integrate, and generalize new knowledge and skills effectively. Large language models, in particular, are quite unable to update their core model in real time. Narrow AI. The second major problem preventing progress towards AI is the focus on particular abilities rather than a general ability to apply its intelligence to a very wide and dynamic range of problems like we can. This does not mean that an AGI should be godlike, but be able to and be able to solve any and all problems. Many, perhaps even most, real world problems like weather prediction are not fully tractable and require highly specialized and optimized systems. What we're looking for in an AGI is the ability to handle a variety of often novel problems and figure out methods and tools needed to solve them effectively without needing a human in the loop. AGIs should fundamentally be excellent generalists and tool users. However, they may go on to specialize. The narrowness of AI is most obvious in earlier efforts like IBM's Deep Blue, the world chess champion. In spite of its impressive performance it couldn't even play checkers. Even today, we have AlphaFold, video generation, and LLM chatbots manually engineered for specific tasks. And I would say even beyond that, like not only can it not play checkers, it can't even detect if its opponent made an illegal move. I would say honestly, I would be shocked if it even had that ability, and that's very much a essential ability for playing chess. I mean, if the uh, opponent moves their bishop to be on the other color of squares, that's a tremendous advantage, and that's something that a human player could easily be tricked by. So it can't even detect if the rules of the game have been upheld or not. So it can't, like, despite the narrowness, allowing it to be the world's chess champion, even that requires such a narrowness that it likely couldn't win against a cheater, because it has no ability to detect and call out cheating. That's a broader application than it's been designed for. The narrowness problem is exacerbated with a constant push for quick results, like beating existing benchmarks, developing MVPs, or narrow products, or being able to publish some incremental improvement. Focusing on wider, more general capabilities yields inferior conventional results in the short run. External intelligence. The next sin is closely related to the previous one. Narrow AI actually implies that the intelligence needed to solve a specified problem derives mostly from the human programmer or data scientist who figures out how to design, build, and tune a system to achieve the desired results. Current systems need humans to understand the real-world requirements of specific applications and use their smarts to engineer workable solutions via fine-tuning, prompt engineering, and external databases, etc. The intelligence is external rather than internal to the system. Real AGI's core intelligence needs to be able to figure things out autonomously. Pre-trained. The tremendous advances in AI over the past 10 years have largely been driven by the creation of ever larger models using variations of backpropagation training. This approach requires that all training data is available upfront, and that training occurs in one continuous process. With current models, this number crunching can take several months to complete and cost tens of millions of dollars or more. Once training is complete and the model is put into production, the core model cannot be updated incrementally in real time. It is read-only. This means that any changes in the real world, like elections, conflicts, scientific breakthroughs, etc., or even corrections on its training data, since the beginning of the training cannot be part of the model. This is a very serious limitation. One can hardly consider a system to be intelligent if it cannot adjust its core knowledge given changing circumstances, which is kind of an interesting thing to say, because I feel like when it comes to the discussion of mis and disinformation, which is a very interesting discussion in my opinion, is becoming more and more clear that even humans are not able to adjust their core knowledge given changing circumstances, and they just kind of lock onto things and don't really seem almost unable to reevaluate their beliefs of those things, especially in light of things like facts. Like they require kind of more than just the facts to change their opinion. They require kind of almost some sort of other mechanism. Not only does pre-training makes with an extra S these models incredibly expensive, but worse, they are inherently disposable. they get used for a few months and are then discarded, forcing developers and users to constantly re-engineer solutions. What does ROI, return on investment, look like on billion-dollar investments deprecated over just several months? And actually, no, that says depreciated. Deprecated means just completely down to zero, but depreciated means having less value. And yeah, so Sam Altman, the man of the hour, said on July 23rd, 2024, I don't care if we burn 50 billion or 500 billion a year, we're building AGI. On February 14th, Sam Altman is seeking 7 trillion to achieve AGI by increasing chip building capacity. And I think he'll get that soon. You know, as I said, I really believe that this is going to become a multi-trillion with a T dollar industry by 2030. All right, and then Larry Ellison, who I believe, he's the Oracle chairman, on September 10th, 2024, said the cost that training gets the cost of that training gets to be astronomical. When I talk about building gigawatt or multi-gigawatt data centers, the entry price for a real frontier model from someone who wants to compete in that area is around 100 billion. That's a lot of money, and it doesn't get easier. Attempts to mitigate this flaw fall into 3 basic categories: fine-tuning the model using large input buffers and complex prompts, and incorporating external databases. Each of these methods has their own limitations and does not fundamentally address the core problem. Quantity. The amount of training data, and thus model size, has been the single biggest factor driving the utility of current AI systems. LLMs now consume tens of trillions of words for training. Obtaining such large amounts of text means scouring the internet for whatever one can find, good, bad, and ugly. LLM hallucinations are partly the result of this data promiscuity. Ultimately, this is not the best way to create robust intelligence. In human education, we try to take care to teach valid, non-contradictory knowledge. Real AGI should focus on data quality rather than quantity. That's such a good point. When you read a textbook, about it just doesn't include, invalid arguments. And then the thing is, like, list of superseded science, like, there's so many. You could spend, like, there were PhDs in vitalism before, right? There were PhDs in telogyny. There was a whole scientific racism. I mean, there were so many, like, there were whole academic institutions based on the idea of biological racism, which is just completely pseudo-scientific given the light of genetics. It was the whole idea of that humanity consists of physically discrete superior or inferior races has been disproven and rendered obsolete by human evolutionary genetics and modern anthropology. We're all butterflies. It's just some butterflies have, different colored wings than others because of the, evolutionary forces applied upon butterflies. None of us are zebras, while some of us are butterflies. That's just not the case for humanity. Some of us are gorillas. Some of us are, there are other species, is what I'm trying to say. But the human species is one of these species, and within the human species there does not exist physically discrete races, especially not in a manner that makes some superior and some inferior. So this is what I'm trying to say, is that when it comes to learning, you can skip all this. It's wrong. You don't have to go back in like the 1940s in Germany and get a PhD in everything they were teaching in their universities. You can skip that and just move right on to evolutionary genetics and modern anthropology instead. So, but the LLMs can't. They have to consume everything they were given. All right, so statistical. Most current AI systems are based on encoding statistical regularities found in the training data. Modern designs encode word or other data relationships to help statistically predict the next item. And one more word about the idea that you can skip like pseudoscientific theories and stuff like that is like, with this model that they're doing now, it's like, how would you know to skip it? Like imagine what you would have to build into the model for it to be able to correctly identify something as a pseudoscience. Like there's stuff that like the standard model of physics is the perfect example. It isn't able to reconcile quantum phenomenon with phenomenon at large scales. So is it a pseudoscience? Like, no, it's good at predicting things, but is it going to be succeeded at some point? Oh, heck yeah. So could you skip it? Well, yeah, you can when the thing that is actually true is discovered, but it's not discovered yet. So it's the best we have. So, there's no avoiding, like in that sort of approach where it doesn't have the ability to reason on its own. Basically, you have to give it stuff that is untrue. There's yeah, you can try to discern it yourself, but I mean, once you do, like, that's it. Like that's what it believes. That's part of its knowledge base, and that's not okay, and that's not how intelligence works. Like, people can look into it further and presumably change their mind. It's just hard for humans to do that because it's an evolutionary afterthought. The part of the brain that does that is is not super robust. All right, so statistical. Most current AI systems are based on encoding statistical regularities found in the training data. Modern designs encode word or other data relationships that help to statistically predict the next item. The statistical randomized nature of prediction is the main reason for hallucinations. Once a wrong token choice is made, the system will try to double down on completing a plausible but wrong sequence. Furthermore, because these items do not form their models by interacting with the real world via senses and actuators, their knowledge representation is not properly grounded. Concepts are formed by token or token occurrence rather than by ontological real-world features. Ontological concepts, like statistical ones, are represented by a dynamically variable number of attributes or meaningful vector dimensions that increase as you learn more details about a given concept. Theory. Finally, the overarching sin is the lack of theory. From first principles, one would expect AGI researchers to start with trying to truly understand human intelligence in order to build it. Not so. The current approach is essentially, hey, we've got a lot of data and compute. What can we do with it? That's the hammer we've got. What nails can we find? There's something seriously amiss with this brute force approach, when you consider that the human brain uses about 20 watts, not 20 gigawatts, and we need just a few million words to master language and reasoning, not tens of trillions. A much more reasonable approach would be to first deeply explore and understand the essentials of intelligence and how the human mind works, which I would love to do, which is why I am reading this. Which is why why I'm applying for this job. I actually, in my youth, read a book on Francis Crick, and like it was, I think it was called "Cracking the Code" by the Genetic Code, by Matt Ridley. No, this is it. Francis Crick, Discoverer of the Genetic Code. This is like the best book I've ever read in my life, and I read it when I was I wasn't that young, but I think I read it right when it was published because I got it from the library, so it was like on their shelf of like new books. And man, this is the best book I had ever read, ever. And there's the last chapter was about like, this is such a important discovery, the genetic code. Like, what is next? And it made the case that consciousness is the next big thing. All right, so a more reasonable approach would be to first deeply explore and understand the essentials of intelligence and how the human mind works, how we learn and reason. Such research would cover epistemically, theory of knowledge, the nature of knowledge, and how we obtain certainty. More broadly, a philosophical understanding of consciousness, volition, and ethics, how we know right from wrong. It would include a thorough grasp of cognitive psychology, how our intelligence differs from other animals, how children learn most effectively, what good IQ tests measure. So they might be looking for more of a neuroscientist, but we'll see. Without a good theory of human intelligence, AGI will at best be stumbled across by accident. By their own admission, none of the current AI leaders have a theory or plan on how to achieve AGI. So here's the three big ones: LeCun, Demas, and Sam. So and I've read these before. This is a repeat. Let's read them again. So on the path towards AGI, an LLM is basically an off-ramp to distraction, a dead end. Deep learning is definitely not enough to solve AI, not by a long shot. We need another breakthrough. Language models won't result in AGI. The 7 sins. Almost all current AI projects commit all or most of these sins. We will not achieve AGI without taking them seriously. One very different approach is what DARPA calls the third wave of AI, or cognitive AI. This is a much smarter path to AI. It requires orders of magnitude less data and compute, and has the ability to learn incrementally in real time. An example of this is aigo.ai's integrated neurosymbolic architecture. Instead of trying to build longer ladders and larger airships, we should be focusing on fundamentally better solutions to avoid sinning. So sinning is kind of an odd word to use there, but so we should be, I guess, boondoggles. If I could replace that word sinning, I would replace it with the word boondoggles, and to avoid boondoggles. So basically the idea is that all of our current approaches to AI are just giant boondoggles, and it's just going to delay our discovery of AGI, which is something completely different than what is currently being worked towards. But I mean, I like ChatGPT. It's kind of been helping me, I think. Well, in between jobs here, applying for jobs, I guess who can say for sure. But yeah. So instead of trying to build rockets versus ladders, you're much better off using a rocket. Planes versus airships, you're much better off using an airplane. And part of the reason is because especially if you can't find a non-flammable material for the the material you're using on the airship. Also, I think planes can go faster, which is a perk. All right. So this was the 7 deadly sins of bad AI designs. So that's this one. Okay. And I don't think I need to get all of these done. It was very unclear which to read, and I was hoping I could read everything, so I didn't take the effort to clarify it. But that took me about 30 minutes, so yeah, unfortunately I might not have the ability to get everything done, but I'll come back after a break and see what else I can knock off. Alright, and actually I got about 10 minutes here, so let's see if I can get rid of a small one in the meantime. Alright, some of these are a bit redundant, so yeah. Oh, this is a white paper. Yeah. These are both white papers. Okay, so I think this is a good candidate to getting read. So this is LLMs are not the path to AGI. So let me mark this off as a not done. All right, and see if I can get this done in 10 minutes. A bold statement. Its validity hinges on the definition of AGI, a computer system that can learn incrementally in real time by itself to reliably perform any cognitive task that a competent human can, including the discovery of new knowledge and solving novel problems. This description aligns with what we had in mind when we coined the term in 2002, and the word "we" there includes Ben Goertzel, who I'm a huge fan of. I've definitely binged a lot of his content online. So it will be all worth it if I get this job. That'll be really validating for me. All right, so real AGI will be able to teach itself any cognitive profession by hitting the books. It will be able to function as an effective researcher or scientist, as a manager, accountant, or assistant. It will be able to perform any cognitive desk-bound job at human-level competence or above. Importantly, it will be able to adapt to new information and changing circumstances on the fly. AGI promises to usher in an era of radical abundance. In order to achieve these lofty goals, an AGI system needs to embody a number of cognitive abilities, including the ability to learn incrementally in real time and to operate largely autonomously, to acquire new skills and to execute them accurately. It is now quite widely acknowledged that LLMs, or generative AI, and more generally purely big data statistical models alone, are not going to meet the requirements of AGI. And we've just recently read this, so there's another one here. AGI is going to require new scientific breakthroughs that we don't know of yet. And Jan LeCun, chief AI scientist at Meta, formerly known as Facebook, said that... what? Oh, yeah, he said that early this year. For some reason, it was year 2023 was still kind of mapped in my mind, so I thought he said that in the future, but the year now is 2024. And then Demis Hassabis, Google DeepMind CEO, says that scale only gets you so far. The biggest breakthrough in AI are yet to come and will take more than just chips. So the question that is asked is why? Why won't statistical AI methods lead to AGI? Well, the name GPT already provides some clues. Generative, they provide responses, make stuff up. They generate responses, make stuff up from the trillions of bits of training data, good, bad, and ugly, causing hallucinations and lack of reliability. They're pre-trained. These models are read-only at runtime. The model can only be updated via expensive, lengthy batch training, 100 million plus for GPT-4, and a lot of those costs are compute costs, electricity. This is why they're buying 3 Mile Island. And then Transformer. This core technology enabled their impressive performance. This core technology enabling their impressive performance relies on a form of backpropagation, which inherently requires batch training. These features make LLMs inherently unreliable, non-adaptive, and expensive. Importantly, this also implies that you always need a human in the loop, both for validating responses that they make sense and for ongoing updates and development. In addition, ongoing human intelligence is also required to engineer prompts. Other headaches for legal and marketing that are LLMs are black boxes, inscrutable, unaudible, explainable, unsafe, and risk potential data leaks and copyright infringements. Is this fixable? Hallucinations, fine-tuning, parameter tweaking, for example, temperature, data curation, and external validation, for example, one LLM monitoring another, are some of the techniques used to improve accuracy. However, the system's inability to tell good data from bad, or when it doesn't actually know, and its lack of metacognition, analyzing its own processes, limits the degree of mitigation. No real-time learning. 2 mechanisms attempting to overcome the lack of real-time learning ability are huge context windows and RAG, retrieval augmented generation. Here are some of the issues with these approaches. Number 1, data in the context window is not properly integrated and structured, and therefore cannot be reliably retrieved or used. Large amounts of context are also slow and expensive to process. Number 2, indexing data both for storage and retrieval is still subject to the usual statistical inaccuracies and hallucinations. Number 3, neither approach actually updates the core model in a systematic or permanent manner. The next problem is black box opaqueness. Modern analysis tools only provide very limited insight into the data structure, certainly not enough to make them explainable. They're also expensive and slow. Various hardware and software optimization techniques can mitigate these missing an S. Or I think these is meant to be this. So various hardware and software optimization techniques can mitigate this limitation, which is that these LLMs are expensive and slow. However, in an effort to make LLMs more useful, models and context windows are growing rapidly, likely offsetting such improvements. Needs a human in the loop. To make LLMs more trustworthy, significant effort goes into the design of application-specific external guardrails. Typically, this ends up as a trade-off between reliability and LLM usefulness. By the time all these mitigation measures, plus others like fine-tuning, are implemented, it often seems like the tail is wagging the dog. In other words, how much are you actually getting out of the LLM versus all of the other more traditional mechanisms? It should also be noted that fine-tuning and partial retraining of models risks catastrophic forgetting. where models suffer unpredictable performance regression. Lack of quality data. Dearth of reliable training data is particularly acute for company specific low volume and specialized domain applications. There simply may not be enough data available to train the model, quite apart from the issue of high training cost for one-off use cases. Automating workflow and procedures, agentic AI. Multi-step applications, like for example, customer support, involve a series of actions such as obtaining information from a user, implementing contextual business rules, reading and updating APIs, and so on. Even an average accuracy of 95% per step quickly deteriorates to 66% after only 8 steps. Clearly unacceptable for even moderately critical applications. All right, so tail wagging the dog, performance issues, cost issues, does not solve multi-step reliability. So LLM, yeah. So no, it does not seem to be flexible. Given these approaches, it makes sense to compare generative AI to an alternative approach to AGI, namely cognitive AI. So I read all this out before. I'm not going to read it again, but we can see that. Okay, so statistical AI is not the term for what the current zeitgeist is. It's a better term is generative AI. Instead, if one focuses on the core requirements of AGI, such as incremental conceptual real-time learning plus high-level metacognitive reasoning, it becomes clear that LLMs are not the path to AGI. AGO's INSA, Integrated Neurosymbolic Architecture, offers the direct path to AGI. So, okay, well, you know what? It's looking more and more like... I mean, to just be an applicant of the job is different than being successful at the job once you have it. But it definitely does seem like I'm going to need to read some very... Oh, you know what? It says implementation details of INSA are proprietary. Okay, so I'm definitely going to have to read whatever they have up about INSA. But, you know, applying for a job is quite different than having it. So if I am hired, I'll likely be spending most of my time, if not all, on INSA, just learning about what that is. And it's all proprietary, so I won't be able to make like a YouTube channel out of it or anything like that. Like that would be the job, basically, is learning about INSA, at least at the very beginning, likely. So. Yeah, I'm in. Sign me up. So with that, I'll take a break here. That one is complete. So yeah. So you know what? When I come back from my break, let's mark INSA as the next one to read. Yeah. So that's this one here. All right. So with that, I'll take a break and be back shortly.